Throughout history, volcanoes have been the source of many cataclysmic disasters. Their eruptions can cause all of the things you expect: explosive destruction, catastrophic ashfall, and devastating wildfires, not to mention whole swaths of land getting swallowed by lava and debris. But one thing volcanoes aren't usually responsible for is pandemics, except for the time that they might have caused the Black Death. Because scientists now think volcanic eruptions could have touched off a cascade of dominoes that led to a deadly bacterium killing up to half of the population of medieval Europe. Beginning in 1347, the Black Death swept across Europe, killing an estimated 50 million people. Now granted, this is medieval times, but that's about 7 times the worldwide death toll from COVID-19 and comprised up to half of the total population of Europe at the time. The deadly pandemic was an outbreak of plague, an infectious disease which causes fever, painfully swollen lymph glands, and black necrotic tissue, hence the black part of the name. The infection also affects the blood, lungs, and can move through the body so fast it causes death in just hours or days. But it was another 550 years before anyone figured out what was actually doing the killing. A 19th century physician studying a new plague outbreak in Hong Kong found the tiny bacterium Yersinia pestis to be the culprit. And in 2011, DNA analysis of skeletons found in plague pits confirmed that Yersinia pestis was the killer in the Black Death pandemic too. The bacteria is normally carried by animals, so it's thought that they were transferred to humans via fleas that infected wild rats. More than 650 years later, I still feel like this is what fuels our collective hatred and fear of rats. Most recently, in 2022, the particular strain of Yersinia pestis that caused the Black Death has been traced to Kyrgyzstan and was known to have made its way across Asian trade routes to the Black Sea by the 1340s. But it's still not clear how the bacterium made the jump to Western Europe, why it spread so quickly, and why it was so deadly. But now, a 2025 study claims to have found an answer, using a combination of climate data from tree rings, atmospheric compositions preserved in ice cores, and historical written records from chronicles, treaties, and even poetry. Together, these clues point to a chain of events like a carefully constructed line of toppling dominoes, which starts with a seemingly unrelated natural disaster halfway across the globe. Naturally, the first domino we're going to talk about is a volcanic eruption. Now, written records from this time aren't all that complete, and there's no definitive historical account matching the eruption the researchers describe. However, scattered writings from around the world, including Japan, China, Germany, France, and Italy, report unusual cloudiness in the years before the Black Death. Some records also mention dark lunar eclipses. During a lunar eclipse, when the Earth casts its shadow on the moon, light filtering through the atmosphere makes the moon appear red. A darker eclipse implies that less light than usual is making it through to illuminate the moon, suggesting there's more stuff in the atmosphere getting in the way, like particles from a volcanic eruption. Now, all of this would be fairly circumstantial if it wasn't for a smoking gun discovered in ice core records from Greenland and Antarctica. In these cores, which are drilled vertically down through the ice caps, there are layers that correspond to each year's snowfall. Layers of snow are buried year on year, turning to ice and sealing in a chemical record of what was going on in the atmosphere that year. And for a number of years preceding the Black Death, researchers found spikes in the concentration of sulfur dioxide in the atmosphere as recorded in the icy layers. In pre-industrial times, the main source of sulfur in the atmosphere was volcanoes, and since its concentration in the ice corresponds to the concentration in the atmosphere, these pulses can be used to pinpoint the time and to some extent the size of past eruption events. Researchers found small sulfur spikes in layers from 1329, 1336, and 1341, followed by a really big one in 1345, 2 years before the Black Death took off in Europe. That last one represents around 14 million tons of extra sulfur in the atmosphere, which has the potential to cause many of the phenomena reported in written records. For comparison, when Mount Pinatubo in the Philippines erupted in 1991, it ejected about 6 million tons of sulfur. sulfur. So at least by ice core reckoning, the 1345 event was more than twice the size of Pinatubo. The researchers don't actually know exactly where the eruption happened, but the global distribution of sulfur implies it was somewhere near the equator, which would have allowed the volcanic gases to move north and south in equal quantities. One possible candidate is Mount Rinjani in Indonesia, which is known to have erupted and produced a big sulfur spike a century earlier in 1257. If that volcanic region had continued to be active, then one big eruption or several smaller ones could have produced the sulfur we see in the ice and the global reports of changeable skies. Wherever it was, though, that volcanic outburst set the stage for the second domino to fall in the shape of a volcanic winter and famine. The sulfur dioxide from volcanic eruptions is an aerosol in the atmosphere which scatters and reflects sunlight, causing temporary cooling. Mount Pinatubo's eruption, with its 6 million tons of sulfur, cooled the planet by half a degree Celsius in the year after the eruption, temporarily bucking the global warming trend. So 14 million tons from a 1345 eruption could be expected to have an even greater effect. And researchers found evidence for such a cooling event in the wood of trees all across Europe. In the study of tree rings, known as dendrochronology, each ring in a slice through the trunk represents a year of that tree's growth, much like the layers of ice in cores. This time, though, it's the size and structure of the rings that give information about the past conditions. In northern Spain, tree slices from this period consistently have what is known as blue rings. Now, these rings aren't actually blue to the naked eye, but rather show up when microscope slides are prepared. Paper-thin wood samples are stained with a special combination of chemicals to show their structure and chemistry. In this, normal wood appears bright pink, while abnormal layers show up blue. Blue rings indicate plant cells with little to no lignin in their cell walls, and since lignin is the tough fiber that makes wood stronger than normal plant stems, it's as if these layers were just never finished. Scientists aren't sure exactly what makes trees leave behind blue rings, but in more recent records, they have seen a link between these structures and cold summers. And while it's fairly common to have one anomalously cold summer, several together is much more rare, and it hints at something bigger going on in the atmosphere. And that is consistent with other data from tree rings. In thousands of trees measured across Europe, rings between 1345 and 1347 consistently have lower density wood than usual from the summer growing season, suggesting cold temperatures and non-ideal growing conditions. And it wasn't just the trees that suffered from these cold volcanic winters. The researchers believe that the lower temperatures would have disrupted normal patterns of rainfall all across Europe. And written accounts from this time confirm this, with reports of exceptionally cold, wet summers between 1345 and 1347, leading to poor harvests and crop failures all across southern Europe. Before long, people in the Mediterranean were facing famine, which was compounded by the fact that many of these populations had been drawn into big cities. Growing urbanization meant that the Italian city-states like Venice, Genoa, and Pisa were so densely populated that they couldn't be self-sufficient. There wasn't enough space to expand nearby agriculture to support their citizens, and so they had to rely on grain that had been shipped from further afield. Usually, they'd use maritime trade routes to import their grain from southern Italy, Sicily, Sardinia, and northern Africa. But when all these crops failed, it left a lot of people with not a lot of food to go around. But before our third domino falls, we need to pause for a quick break.
Thanks to Storyblocks for supporting this SciShow video. At SciShow, telling stories through video is our bread and butter, and the people behind Storyblocks feel the same way. Storyblocks is an all-in-one creative toolkit built to help you tell stronger stories in your videos. It provides you with a stock library of over 7 million assets, including footage, music, sound effects, templates, and workflow-enhancing tools. And that library was curated by real filmmakers and artists around the world. They add real, professionally produced footage to the stock library to help elevate your videos and make your stories stand out. And it's all in one place, so you can move from idea to finished content faster. It's all about speed and simplicity. On average, Storyblocks saves members 3.5 hours every week, so you can upload more videos, like 85% of teams do after switching to Storyblocks. Thanks to thousands of customizable templates, you can add motion graphics like title animations, overlays, and logo reveals to elevate your storytelling, and access the Storyblocks library all in the same place using the Storyblocks plugin for Adobe Creative Cloud. For all of those storytelling tools, head to storyblocks.com/SciShow and get 15% off any annual plan for a limited time. That discount is only available through the link in the description.
And now, we arrive at our third domino. In the past, a famine like this would have meant that many people would have died by starvation, but these late medieval Europeans were far too sophisticated to starve to death. The key was those Italian city-states and their overseas trade links. The cities had been cultivating a relationship with the Mongols in Central Asia for the last 100 years, and now their governments called on those contacts to save their citizens. Further north, Asian grain-producing regions are thought to have not been so severely affected by the climatic downturn, and there were already established trade routes between Italy and the Sea of Azov in the north of the Black Sea. Okay, sure, so the two peoples were in the middle of a war while all of this was going on, but the famine forced them to negotiate a ceasefire. Funny that! Trade routes were reopened and grain began to flow again. The Italians were saved from starvation, but unbeknownst to everyone, something else was lurking on those grain ships. Our final domino, the arrival of the plague in Europe. Those ships that carried grain from the Black Sea also carried fleas infested with Yersinia pestis. It's likely that these fleas didn't even need rats as a host, which may have been ousted from the ships if found in the grain. Instead, the tiny insects survived the journey, feeding directly on the grain dust. The Mongols had been dealing with their own outbreak of plague after that new strain from Kyrgyzstan we talked about earlier had spread over land. But at the time, nobody knew what caused the disease or how it was transmitted, so the Italians had no way of understanding the risk of trading with Asia. The ships arrived, the grain was unloaded, and the affected fleas spread to rodents and domestic animals, and before long, humans. When you look at the timing and locations of the first Black Death outbreaks, the link to the Mongol grain seems clear. Whenever grain shipments arrived, the first cases of plague soon followed. For instance, in Venice, the first cases occurred less than 2 months after the grain shipment. And when there was enough surplus for grain exports to resume from Venice to another Italian city, Padua, we see a plague outbreak there too. Meanwhile, larger Italian cities like Milan and Rome were more agriculturally self-sufficient, and dedicated grain-producing regions like Verona and Ravenna managed to get by without importing grain, and all of these places were protected from the first wave of plague. And so, the Black Death in Europe was as much a product of global circumstance as it was an infectious bacterium. Chance had set up these medieval dominoes just right. Natural events, global climate, demographic distributions, and socioeconomic responses were aligned in a perfect storm to create the worst of all possible outcomes. In fact, this is an early example of how globalization can be both a blessing and a curse. Those far-reaching trade links helped save everyone in northern Italy from starvation, but they were ultimately responsible for killing just as many, if not more, with the plague.